Whew, there's a bunch of data sets capturing the traffic flow of cars taken at every 15 minutes. Hey guys, welcome back to my YouTube channel. So in this video I'm so excited because I decided I wanted to do a data set related to traffic safety. So I found this data set on Kaggle and I'm so interested in sharing with you guys my project related to traffic safety. Let's get into it. Alright guys, so here's my project. My project title is called On the Road to Safety, Predictive Modeling of Traffic Flow for Effective Crowd Control. And my project highlights the use of predictive modeling and traffic flow analysis to enhance crowd control and safety solutions. And it basically aligns well with my project focus on leveraging traffic prediction data for strategic insights and improvements in safety measures. So you can see I have a image of LA with all the traffic in the background. And I put the interstate. So it'll be like that. So here's my storytelling. And before I get into the storytelling, I want to show you that I'm working for this company. Well, I'm just pretending to be working for Brimar Industries. And basically, Brimar Industries is a manufacturing company that specializes in manufacturing and selling safety signs, street signs, vault tags, parking signs, crowd control products, and mailing tabs. And their ultimate mission is to provide innovative safety solutions through top-notch technology, excellent customer service, and superior product quality. And basically their goal is to aim to lead the industry in creating and distributing safety products that enhance global safety. And that's how I'm going to use in my project. And through the storytelling, I'm going to share with you some ways on how to. So I'm basically a committed data analyst and at Brimar Industries utilizing advanced SQL techniques to thoroughly analyze a complex traffic dataset, employing window functions. I identify crucial peak traffic periods to enhance crowd control strategies. Subsequent queries highlighting days with above average traffic, guiding proactive safety measures. By pivoting the datasets, I conduct detailed hourly analysis of CarCount, BikeCount, BusCount, and TruckCount, crucial for understanding traffic dynamics. And I apply mathematical statistic methods, including the Neyman-Pearson lemma for peak hour traffic testing, the methods of maximum likelihood for traffic parameter estimation, and comparing bias and variance across traffic flows estimators. I also can incorporate non-parametric tests, status tests of weekday, weekend traffic differences, ensuring customized management strategies, a scatter plot in determining the correlation, highlighting the significant impact of car traffic on overall volumes, and aiding the development of predictive models for real-time traffic management. And these comprehensive analysis provide actionable insights for optimizing traffic management and safety measures at Brimar Industries, enhancing efficiency and safety across urban landscapes. And here are some questions I want you to keep in mind when I'm presenting this is, how do traffic patterns change seasonally? Are there distinct trends that influences safety products demand throughout the year? What are the effects of outliers on traffic predictions and safety measures? How can outlier detections improve the robustness of the traffic flow models? How can Brimar Industries collaborate with urban planners and authorities to integrate safety products into city planning based on traffic analytics? What strategies can be implemented to tailor safety product offerings to meet specific client requirements based on traffic data analysis? And what advancements in technology or methodologies could further enhance the accuracy and applicability of traffic flow predictions? So getting the data set and the software used, I got this data set from Kaggle. This had a great data set when comparing traffic prediction, and here's the URL where I got it from. And this is the Excel spreadsheet. You can see the time indicates the time of observation, the 24 format. There's over 2,000, approximately over 2,000 rows. So I wanted to just show you the 5. And basically each of these represents observations taken at a 15-minute interval, capturing the traffic flow metric and situation classification for each time slot on the specified date. And this dataset provides a detailed snapshot of traffic conditions over time, which can be analyzed to understand patterns, trends, and correlations among different vehicle types and their impact on traffic flow and safety. And you can also see there's the date of the week, car count, bike count, bus count, truck totals, and traffic situations. So here I used the window function to rank the traffic counts total by given a day, showing the top 5 busiest periods. And given the output of the 5 busiest periods on a Friday, I can derive the following insights: that the busiest time is from, we can see that the busiest time is from 1 o'clock, and this period shows the highest traffic counts, indicating that middays on Friday experiences a significant surge in traffic. And the second busiest is in the morning at 8:30, which is a critical time for traffic management, and around 8:15, which is around night periods, also shows a high traffic, reflecting another peak, which is likely due to post-work commute. And at 3:30 in the morning, I also noticed that there is unusual traffic activity, which could be due to night shifts, or maybe some people or workers doing deliveries, truck deliveries, like the UPS or other factors. Those are some other possibilities. And at 1 o'clock a.m., although lower than the others, we can see a late night, early morning period still falls within the top 5, pointing to notable activity even at off-peak hours. And here's a subquery calculating the average total traffic count across all days. That's where the actual total count exceeds the average. And you can see here there's the code I wrote and also the data. And we can see that consistent high traffic in day 10 appears to have the highest. And this could indicate regular events, activities, or commuting patterns that cause increased traffic on this day. And also peak demand identification, meaning recognizing these high traffic days, which helps in planning for higher demand for safety products and services. Also for resource allocations, more traffic management resources to handle the increased traffic efficiently. So this can include deploying additional personal safety barriers. And here I transfer my data to pivot the car count, bike count, bus count, and truck count into separate columns. And in this pivot format, car count 1, car count 2 represents different counts for cars, bikes, buses, and trucks at specific times, or specified times. And you can see that we can identify which vehicle type is the most prevalent at specific times. For example, high truck counts at 1 a.m. suggests that early morning hours might be significant for freight or delivery services, and demand forecasting, which anticipate higher demands for safety products and traffic management services for particular vehicle types at certain times. Also, for research optimization, target deployments, which allocates traffic management resources based on vehicle type distributions at different times. For example, if truck counts are higher during the early morning hours, we could focus on providing more traffic control measures suitable for heavy vehicles during those times. And also time-sensitive strategies, which can implement the strategies to address the unique needs of different vehicles types throughout the day. And here I wanted to get into the mathematical statistics I want to show you. And here I use the Neyman-Pearson's lemma using R. And the purpose is to test a hypothesis about the mean traffic flow during peak hours. So basically, I calculate the likelihood under the null hypothesis, in this case mean is 100, and alternative hypothesis, which is 110, and then compare the likelihood ratios to make a decision. And basically, the output is whether or not to reject or to fail to reject a hypothesis based on the likelihood ratio being greater than the specified threshold. In this case, the decision is based on the overall likelihood ratio, and we can see that it rejects the null hypothesis, indicating that the mean traffic flow likely exceeds 100 during peak hours. This result, I conclude, suggests that during peak hours, the mean traffic flow likely exceeds the assumed threshold of 100, and this is crucial for planning crowd control measures and safety protocols during high traffic periods. And also here's the maximum likelihood estimator using R, which I remember from my mathematical statistics. And the purpose of this is to estimate the mean and variance of traffic counts. And the method I use is to calculate the sample mean and variance from the observed traffic data. And I also noticed that the mean for the traffic data count came to be 114, and the variance came out to be 3,622.91. Well, that's just 3,623 to round it up. And the estimated mean traffic count indicates the average expected flow, while the variance gives the insights into variability around this mean. And here's an unbiased and biased estimator. And the purpose is to compare estimators that may be biased or unbiased in estimating traffic flow parameters. And the method is to calculate the biased estimator, or in other words, the mean of the car count, and the unbiased estimator, the adjusted mean of the truck count. And we can see that the biased estimator for the car count is 68.69657, and the unbiased estimator is 15.3300. And the biased estimator the car count may be influenced by the disproportion represents of the car data, and the unbiased estimator adjusted or the truck count provides a more balanced estimate considering the sample size. And here's the robustness using predictions using R to assess how robust traffic flow predictions are to outliers or extreme data points. And I use robust statistics to calculate the measure of central tendency and variability that are less sensitive to outliers, or in other words, the trend mean. And the output shows that the robust mean is 111 for the mean traffic flow, and the variance is 3,622.912, indicating stability in traffic flow patterns despite potential outliers. And the robust mean trimmed by 10% provides a less sensitive measure to outliers in the data. And the consistent variance indicates that traffic flow patterns are relatively stable across the dataset. And I also wanted to incorporate non-parametric tests, so I decided to use the Wilcoxon sign range test. And this is a useful test to use to compare traffic flows between different days of the week. So I decided to just compare Tuesday and Wednesday, for example, without assuming normal distribution. And my method was to conduct the Wilcoxon test to assess if there was a significant difference in traffic flow between specific or specified days. And here was the output. I could see that the output was, W is 114.28, and the p-value is 0.7851. And the p-value of 0.7851 indicates that there is a 78.51% probability of observing a test statistics at least as extreme as 114,028 under the null hypothesis. And the non-parametric test suggests there is no significant difference in traffic flow between Tuesdays and Wednesdays. And this finding implies consistent traffic patterns across mid-weekdays, which can inform operational planning for safety products. And here you can see my scatter plot effectively visualizes the relationship between the car count and the total traffic count, with addition to the dimensions represented by the bus count, the size of the point in the days of the week. See the X on the X, there's car count, and the Y, there's the total traffic count. And I can also see there are some key observations. There is a clear positive correlations between car count and total traffic count. So as the number of cars increases, the total traffic count also increases, which is expected since cars constitute a significant portion of the total traffic. And we also see that the bus count impacts that the size of the points varies according to the bus count, but there doesn't seem to be a clear pattern where higher bus counts are consistently associated with higher total traffic counts. And this suggests that buses, while contribute to total traffic, might not dominate the traffic flow in the same way as cars. For days of weeks of variations, the different colors represents different days of the week, and there doesn't appear to be a dominant color in any specific area of the plot, suggesting that the day of the week does not significantly alter the overall relationship between car count and total traffic count. And the traffic distribution shows that the plot has a wide distribution of traffic counts, especially as car count increases. And this indicates variability in how other vehicle types, including bikes, buses, trucks, contribute to the total traffic at different car counts. And also some detailed insights I wanted to provide to you is critical peak analysis, which is a high density area in the plot where points are more clustered. So you can see all the plot points here are clustered, which can indicate times of days or days of the week when traffic is particularly heavy. And these insights can be guided targeting interventions for traffic management. So to summarize it, let's go over this. So we can see that weekday versus weekend classifications does not affect the median traffic flow significantly. And based on the analysis that weekday versus weekend classification does not significantly affect median traffic flow, we can see that there are some future interpretations that I can consider, including the stable traffic patterns. And the consistent median traffic flow between weekdays and weekends suggests that overall traffic volumes are relatively steady throughout the week, and the stability can inform long-term planning for infrastructures and resource allocations. Another is uniform safety measures, and given the lack of significant differences in median traffic flow, safety product deployment strategies may remain consistent across both weekdays and weekend, and this uniform approach can streamline operational logistic and resource management. Another is a event-driven analysis, and while median traffic flow remains consistent, future studies could also explore how specific events or local activities impact traffic patterns differently on weekdays versus weekends, and this analysis could uncover nuances that affect safety and operational strategies. And we can see that traffic patterns can vary seasonally due to weather conditions, holidays, and local events. Winter may be reduced traffic due to weather conditions, while summer may experience increased tourist traffic. And I wanted to point this up that during winter preparedness, during winter months when traffic may decrease due to adverse weather conditions like snow or ice, safety product deployment could focus on visibility and road conditions monitoring, and this might include enhanced scenic road surface treatments and weather responsive traffic management systems. And also, the point with the summer traffic management, with increased tourist traffic during summer months, safety strategies could prioritize areas prone to congestions or accidents, and this could involve a real-time traffic monitoring, temporary signaging for events, and optimized traffic flow management to accommodate higher volumes. And also for Brimar Industries, they can collaborate with urban planners and local authorities to integrate safety products into city planning processes, meaning that collaborating with them could present opportunities for the Brimar Industries to integrate safety products. One is data-driven planning, which is traffic insight integration, and by sharing traffic flow analytics and safety product recommendations with urban planners, Brimar Industries can contribute to data-driven city planning insights on traffic patterns, congestion points, and safety needs that can inform infrastructure projects and road maintenance schedules. They could also optimize infrastructures, meaning urban planners can use traffic data to optimize road layouts, signal timings, and pedestrian pathways. And this integration ensures that safety products such as barriers and reflective markers are strategically placed to enhance traffic safety and efficiency. Also, for safety enhancement initiatives, they could also target safety solutions, including collaborative efforts, which can allow identification of high-risk areas and the implementation of target safety solutions. For instance, urban planners can prioritize the installation of safety signage and speed control measures in school zones or near busy intersections based on traffic data insights provided by Brimar Industries. And also for long-term sustainability and growth, we can see that scalable solutions by integrating safety products into city planning processes, Brimar Industries can scale its operations to support larger urban development projects. And this enhances the company's market presence and contributes to sustainable growth in the safety product industries. And also for future advancements in technology can enhance the accuracy and timeliness of traffic flow predictions, such as the integration of IoT and sensor networks, and real-time data collections of IoT devices and sensor networks, which are embedded in vehicles, road infrastructures, and urban environments, will enable continuous real-time data collection on traffic patterns. And this wealth of data will provide a more comprehensive and current view of traffic conditions. Also, for predictive analytics, there's advanced machine learning that can process real-time data streams from IoT sensors to predict traffic flows with unpredicted accuracy. And these algorithms will adapt and learn from new data inputs, improving predictions model over time. And finally, we can see that the insights from the scatter plot can be leveraged to develop predictive models for traffic flows. And real-time monitoring of car count can help predict total traffic volumes, enabling proactive measure management and crowd control measures. So by using predictive modeling for traffic flows and analyzing historical data from my dataset, I can develop predictive models that forecast future traffic volumes based on factors like the time of the day of the week, and the traffic situation. And like I said, machine learning algorithms such as models or time series forecasting techniques can be applied to predict total traffic volumes accurately. And real-time monitoring of car count along with other vehicle types allows for intermediate insights into current traffic conditions, and it can be used in my predictive models to adjust to optimize traffic management strategies for real time. For example, detecting sudden increases in traffic can prompt proactive measures like adjusting signal timings or deploying additional personnel for crowd control. So thanks for watching my project. I hope this was beneficial, especially with the traffic going on and all the causes and delays. And Brimar Industries is a useful and helpful company. So hope you enjoyed this video, and please subscribe to my YouTube channel as well.